Okay, Dad, let's go. Time to learn. Hour and a half. Let's get it. Or time to lock the info in. Hour and a half starts now. Let's get a quiz going. CPP through chapter 10 now, or into chapter 11 now. Okay. Yeah, how they're differentiated, and then how specifically they're resolved from. Okay, so we've got the general way of function overloading, how functions are differentiated, the general purpose, implementation on the function side, and then implementation on the call side, or at least how interpretation from the call side. Okay, cool. I don't know what the hell it's doing, like what these chapter names are. Oh, it's talking about chapters 8. Well, I guess it doesn't know. This is chapter 8, and it goes through 8:15. Okie dokie. Let's get it. Okay. How do we compare floating point numbers? I think we have to do it as literals. I don't think we can do it as existing ones. Well, I don't know. I mean, you should be able to do it as literals, but I guess you shouldn't because it would be the same thing. It's just that floating points are represented in binary fractions, which which don't accurately represent them. There's rounding. You can't accurately say 0.323 whatever or point 0. Hmm. Okay. Mm, a statement is an individual instruction for the individual instruction for the. Mm, typically terminated with, well, it has to be terminated with a semicolon. Um, I mean, but I guess we say if statements are the whole thing, so you could say the condition part doesn't. What else? In expression statements, semicolon. Basically, always, that if we're calling an if statement, or well, an if statement, then the condition part doesn't have a semicolon. Oops, this needs to be numbered. Variable definition is telling the compiler that the variable exists for the first time. Variable definition is when the compiler is So the first time that a variable exists. Definition doesn't, well, require explicit initialization because a defined but uninitialized variable is default initialized, which giving it an undefined value since it's technically uninitialized. Initialization is the first, well, it's assigning variable a value during definition. Technically, all variables are initialized at definition, but not explicitly initialized, like for default uh, initialization. Undefined behavior isn't explicitly defined by the C++ standard, so it's unpredictable. Uninitialized variable is assigned or is the value of whatever that spot in memory already had, or perhaps some compilers assign a default value to it. In general, we don't know because the C++ standard doesn't define what should happen. So behavior is implementation specific. Excuse me. using standard character output will output text and variables to the console via standard character output and the insertion. Standard inline flushes the buffer, which isn't needed when we output text to the output values to the console. Oh, glasses aren't on. I should probably keep them on. I don't know what the hell my computer was doing. I was trying to get it working for like 5 minutes, and the brightness was minimal. I just had to restart it, but it was extremely hard to see and actually explicitly restart it instead of just powering it off and on, which doesn't restart it. The inline character doesn't flush the buffer, so it's more efficient. I believe output the output that standard character output outputs is destroyed after reading, so flushing the buffer is redundant. Be critical in evaluating my responses so I learn from my mistakes. Is there? Yeah, I thought so. It's a big smudge on the glasses real quick. I'm not super anal about them, but yeah, like that's just insane. I don't know how I missed that mistake. Okay. It's probably because I took it out of the case without doing anything better. Okay. 5. Keywords are words, what do we call it? Restricted, reserved by the C++ language that can't be used as identifiers. They have predetermined functionality, like data types, exit codes. What else? Data types, exit codes, like continue or um, continue, break, return, int, float. I think that's mostly what I even see. Yeah, I think so. I just said like, oops, data types and exit codes. The 6 basic types of variable initialization. Default initialization. Well, okay, so you've got default initialization, the undefined initialization of an uninitialized variable. Copy initialization. Copying the right operand's value to the left operand variable. So there's default, there's brace, there's this, um, fuck, there's default. I'm probably missing two. Oh, yeah, I think I know them all. So there's default, there's copy initialization, there's list initialization, mm, safer than copy initialization and copy and direct initialization because it detects narrowing conversions. Direct initialization using operator assignment. Just a semicolon after the variable. Somehow different than copy initialization using operator parentheses, using operator braces. Copy direct initialization. No clue how it's different. I mean, it seems like it's copying, so I don't know how it's. I don't know. Copy or direct uses equals parentheses. And then there's copy list initialization. No clue how it's different than copy or list, but uses equals parentheses or brackets, braces. I'm pretty sure I can say int x equals 4 like this. Right? Yes. There's default, there's copy, there's direct, there's list, and then there's copy direct and then copy list. But I only ever use list really. And maybe default. Well, maybe copy sometimes, but Not really. I mean, we use operator, the assignment operator, but I don't really ever do copy assignment. Simple program that asks for two integers and outputs their sum and difference. I mean, int, get int, and then I could put bool is first call, enter an int. Well, we could say if is first call, output, enter an int, else, enter another int, and then int, user int. We need to include iostream. Okay, and then we'll say int first int is get int, and we'll say true, and second int is get int false, output sum first int plus second int, difference first int minus second int. Twelve, 6. Okay. All right. 8. Value returning functions. I mean, let's return a value to the callee or to the caller. While void functions return nothing and solely perform side effect. 9. Oh, motherfucker, dude. 2. Or we'll just say fuck it. I'll just name them as is. It's fine. 1, 2. Function parameters are local variables within functions that are initialized using argument values that we pass within a function call. 3. Local scope is the location we can use a local variable. But then it's the range of code spans from variables definition to the end of the scope. Variable isn't visible outside of the scope. Oh, and this should be a block. Or block it block it was defined in. For forward declarations tell the compiler that a variable or function call is valid and that the linker. This prevents compiler errors, and the linker can link the definitions to the calls. Also, if a function uses definition that is later in the code, a forward declaration tells the compiler that the calls are valid even before seeing the definition. Namespaces are isolated sections of scope within are isolated pieces of global scope that we use the scope resolution operator to access. And their names this way, same identifier functions such variables can be defined within global scope but in separate namespaces and not conflict. Header guards prevent compiler redefinition errors that including header file or prevent including a header file in one file more than once in a .cp file. That multiple include generate a compiler error if the header includes definitions. The error would be a notable redefinition. Well, really, it should be a compiler redefinition error. Oh, fuck, I pressed insert. Oh, there we go. Syntax errors are misuses of the language that the compiler will catch and error. Forgetting semicolon. Using comma instead of semicolon during a for loop signature. Loop line, not the body. Still don't know what that's called. We're using, okay. Semantic errors are misunderstandings by the programmer. Decrementing unsigned integer, which accidentally loops infinitely. Off by one errors by using the wrong relational operator in a loop. Accessing a local variable that shadows an outer variable instead of using the scope resolution operator to access the outer variable explicitly. Oh, motherfucker, dude. This is 1. This is 2. Hmm. Debugging process involves finding where the area/unit that contains the error. Find debugging techniques to identify where the error is, and further debugging techniques to see why it's in there and how it's caused. Stepping into over functions can help functions to watch local variables, can identify when values become unexpected or when behavior changes. Breakpoints help skip working code to skip go straight to the area you are um, wanting to step through. Oh, want to watch and investigate. Stepping over helps skip functions that aren't affected. Okay, breakpoints. Skip code before the line for the breakpoints line. Jump straight to where you want to examine. Stepping lets you watch variables change line by line to identify where an error occurs. Bug occurs. This should be bug, not error. For watching variables helps by confirming when expected values remain expected and identifying when they become unexpected. The call stack keeps track of where are in program's execution and what calls must return to complete the program all the way through main. I mean, there's input validation is useful. Oh, what the fuck is happening here? Okay. Using asserts and unit tests. What do we call it? An integrated test? Oh, I think it's too hot. Let me update the AC real quick. Using asserts, unit tests, and integration testing helps validate, helps examine assumptions, examine runtime slash compile time assumptions, validate slash examine expectation, unit expectations, and confirm behavior after including a new unit. And the fundamental data types. Um, integral types, interrelated types, characters, booleans, uh, interrelated types like character, short, int, long, long, unsigned counterparts, floating point values, well, in this case, booleans, characters, floating point types, float, double, long, double. If we, well, I don't know if those are fundamental. If we're talking fundamental, we've got integral types, we've got floating point types, um, void, null pointer, standard string, C style string. Some of those require headers to include pieces of the standard library. Okay, signed integers have half their memory split as positive and half as negative. Unsigned have all memory as positive, so decrementing below 0 yields the maximum value. Hey! Let me let these dogs in. You ready? No? Okay, and they're going. Alright. If I hear more barking, I have to bring them in. Okay, I have to bring them in. Hey! Copper, come! Come on, let's go. Alright. Hey there, good boy. Good boy. Good boy. You're barking, dude. Need all that? Okay. Anyway, continue. We got unexpected behavior like infinite loops, no negative values. I mean, just worse kind of overall, I think. I mean, they're just not as helpful. Helpful when, not when we don't need the values, and memory is limited. So we want as many positive values per variable as possible. Size of pass size of an existing variable or data type to see how many bytes as a size t that it has on this implementation architecture. Okay. Floating point numbers are not decimal, because decimal is the method of counting, are numbers with decimal points that are represented using binary fractions. Very large and very small numbers can more easily be expressed using sign notation, where e substitutes 4 times 10 to the something, 4 times 10 to the power of, so you put the first sig fig in front, usually, which should be less than 10, and the powers of 10 in the back, i.e. 0.000 could be 8.3772 E 1, 2, 3, 4. Boolean values are true. What is this dog up to? Dog is getting squirrel. Unreal. Boolean values are true, false values. True or false? True, false values. 0 for false and non-zero for true if converting from an integer. Used in if statements. If statements execute their body only if their bodies only if the condition is true. So if we put a Boolean value in the statement, that value determines whether the body is executed. Characters are stored as one byte integers and are printed as ASCII values. To print them as integers, we must static cast them to a larger integral type because the compiler is only aware of one fundamental 1 byte integer, which is the character. So even the int 8t's print as characters. Need to change the type to print it as an ASCII code number instead of the ASCII value. Static cast converts the parenthesized type to the type inside angled brackets. Use it when we need to explicitly tell the compiler that we want to convert a value to another type, like when printing chars as integers. Constant variables are variables assigned at compile time with values that cannot change. Use the const keyword to declare, or const expression keyword for more compile time optimization. Const qualified variables can be forward declared, but not const expression variables. Decimal counts by powers of 10. Well, is it powers of 10? I guess it is. Or hold on, it's like, so we can count up to 10, and then we can count tens. Yes. But powers of 10. It's like in multiples of 10? What do we even describe it as? Multiples of 10? So is it the multiple of something up to 10? 10 for decimal is powers of 16, and binary is powers of 2. Um, First number counts up to up to one less than the power number. So in decimal, the first number is not spans 0 to 9, 0 to 15 in hex, and 0 to 1 in binary. Subsequent numbers are the numbers of powers of 10, of powers, the numbers of powers, the numeral value, 10, 16, 2, something like that. Constant expressions are expressions that evaluate to a constant at compile time. Const expression is 100%, or well, must 100% be known at compile time, while const doesn't have to be. Compiler will optimize const expression values all it can. Only has a chance to do that for const variables. Standard string is included via string header within standard library. Expensive to copy. Created upon definition. Well, I mean, treated as any other variable. Lifetime wise. C C style strings are created on program start and are destroyed at program completion. Not really sure how else they differ. Standard string view can be assigned a standard string to access the standard strings value and read only value for cheaper passing. Greater precedence is the operator order of operations, which should execute before which. Associativity is the let's see, the direction that operators evaluate. So, or operate. So right, like if we had something plus this to this, so evaluate all the things that have precedence, this and then this and this. We can group them so that we know what happens, what happens, what happens. And then the final result and determines how the final result is obtained after executing operators in order of precedence. 2, 3, 4 plus 3 minus 2 is assigned, well, fuck, I don't even know. Evaluates to, well, we get 2 times 2, so it's 4 plus 3 minus 4. I mean, at this point, it doesn't matter. After precedence, then 3 minus 4 is negative 1, 4 plus negative 1, 3. After associativity, though it doesn't matter for sums, to cumulative property, I think. Then we assign the final value. Since braces, operator braces must have lower associativity. Well, I guess not. Because we can't say like this plus something. We have to evaluate something first. So Like if I said this plus this, or this squared, this something something something, regardless, I have to evaluate whatever's in there first. I can't say, hey, the parentheses takes priority, so parentheses first. Well, bro, I still have to evaluate what's within it. So it's not that the brace operators have lower precedence. It's just that I have to evaluate the shit before. Otherwise, I don't know what the value is. Arithmetic op operators, a regular mathematical operators. Operator plus, operator minus, operator multiplication, operator division, operator remainder. They're binary and evaluate. I mean, what do you mean, how do you use them? Evaluate to the result of the two operands. I don't know. I mean, it seems like that's it. Um, increment and decrement either increase or decrease the unary operand by 1. They evaluate to the operand either before or after increment, after the side effect of assigning the updated value to the operand, depending on whether they're prefix or postfix. Comma operator splits an expression into evaluating the left side, then the right side, and discards the left side. Right? If I said int something is 3 comma something, well, 3 comma something evaluates to whatever the fuck the something is, so it just discards the left side. Conditional operator assigns the true value if the condition assigns 1 value if the condition is true, or the other if false. Both values and the condition are included within it. Hence, ternary, 3 operands. Relational operators compare the left and right, the binary left-right operands. Like logical operators, return true or false. Logical operators if not something, or if both operands are true, or if either are true. Don't compare floating point numbers because binary fractions create rounding errors, which create inaccuracies. Greater, less than is okay if the numbers are sufficiently different, but equivalency is likely going to be wrong. 1. Bit flags are unsigned ints that have a specific bit turned on, so we can turn on or off that specific bit in our target unsigned int called a flag. Oh, well, sorry, that's bit mask. Our binary, are sequences of binary integers that are updated using bit mask. Standard bit set is a way to the standard bit set object has member functions for evaluating slash updating bits inside the flag, which may be more convenient than bitwise operations. I disagree. Bitwise operators can shift or can, well, so there are bitwise, there are logical bitwise, and then there are just bitwise operators. Can shift, not shift, and then unsigned, or can shift bits in an unsigned int like this or this, like the left shift or right shift operators. The logical operators or logical assignment ones can yield flags bit sets that evaluate to flipped um, flipped flag results or results or all bits that are all bits that are true in both flags or true in either flag. The logical assignment operators can assign flags to those results. There are different ways of converting, but binary 2's complement, at least, is easy enough to convert. The unknown powers of 2 could implement this in a for loop with, let's see. So I could evaluate the first bit and then shift the right one, and then if it's this, add this, and then shift it again. If it's this, add this. If it's this, and then shift, and then let's see. So we could continue shifting, or we could say, or we could have a bit set and say dot the current number, or I could just shift it however much and add that, or that, add that times 2, or add, or start with 2, and then each time, so we say this times 1, this times 2, or start with 1, and then shift it again, and then times, I'm trying to think of when we shift it. I guess we have to pass it the length of the whole guy. So how do we even tell that? How do I get the length of a bit set? Because if it's all 0, and I say, hey, go until it returns 0, it's not going to work. I could I could turn bits on. If I turn them all on, I could shift them until the left side is off, maybe, and count that. But I could implement this in a for loop and keep adding increasing powers of 2 for each right shift 2 and right shift the flag to count in decimal. Would need the length of the flag to be the loop variable, so we continue until the loop flag is until we finish counting, until we count every bit. 7, 8, 9, 10, 11. Okay, I think I can do this. Combo blocks, execute code statement by statement, and local scope begins at operator this and ends at operator boom. Namespaces are sections of our compartments of global, or well, within the global namespace and are isolated scopes within it that you must access via the scope resolution operator and the namespace's name. Is when a local variable. Oof, what the fuck? What the fuck? What is my phone fucking doing? Okay, 27 minutes. More time than I thought. So when a local variable shares an identifier, well, shares an, well, an inside with an inner variable shares an outer variable's identifier, and calling the inner variable, well, and calling the outer variable without the scope resolution operator yields the inner variable because the compiler prioritizes the inner variable when they share an identifier. Gotta use the to get the outer variable. 4. Internal linkage means the function variable is invisible to the linker and is only usable in the current file. External linkage means visible to the linker, so forward declarations in other files will work. Forward declarations and calls within other files will work. Non-constant global variables are changeable anywhere they're used and are probably better off in a namespace or as a local variable, as a static local variable. Well, I don't know about static though. Yeah, yeah, it could be good because then it's basically because global would be a step up. Static means okay, we need a global lifetime, but do we need it to be accessible everywhere? Nah. And then global would be you do. Inline functions slash variables can be defined multiple times in the same scope, and the linker will deduplicate the redefinition. For functions, well, hold on. How does this work specifically for the variables? For an inline variable, it means if I just said, oh, it's to get global constants, yes. They're global, so this lets us either use inline expansion for functions included in multiple files, or use global constants with compile or with const expression optimization without violating the one definition rule. 7 static local variables are local variables that are created at program start, initialized with a blank /0 value, depending on the data type, and initially given a initialized once actually, or once their once their function function their function is called. Lifetime lasts until the end, until program completion. The value changes persist between function calls. Local variables are destroyed at the end of local scope, so their values don't persist. Oh, using declarations. Well, using declarations bring a whole namespace into scope, so we can use all the functions slash objects slash variables without resolving the scope. Using directives, bring a specific function variable object into scope, so we don't compile as much, but can still use that identifier without scope resolution operator. Oh, I don't know what a fucking inline namespace is. Fuck. Unnamed namespaces. Bring everything included inside them within the next outer namespace scope, but with internal linkage. Can't remember inline namespaces. I thought they were similar somehow. Like you could do an inline unnamed namespace, but can't remember if it makes everything inside inline. So then you could just put it inline and then you include that the header file in places with the definitions. No, well, I don't think it makes everything inside inline because, well, I don't know if it fucks with the scope or not. If it makes everything inside inline, it could be a convenient way of doing a bunch of const expression global constants or function or inline expansion for functions. If statements, um, if statement conditions determine whether the body, and thus code, executes. Depending on Boolean values, the flow will change. Gives multiple possible execution paths. Blocks create local scopes to reduce name conflicts. Yeah, I think that's fine. If the semicolon after the condition will be is a null statement, so the body will always execute because it doesn't depend on the condition. Dangling else we have like an if statement and an else statement and then an if and then outside of it an else statement. Should be caught by the IDE, doesn't make but obscures whether it attaches to the if statement immediately before it, true, or the one before that, if the previous if statement is nested. If const expression statements evaluate at compile time. Switch statements execute code depending on which specific value a watched variable, well, the condition variable, the specific value the switch variable matches. Oh my god. Wait, was it that? Or was it a dog? Oh, it is a dog. Jesus, I thought that was the fucking scent thing. You coming in? You coming in? You coming? Come on. Oh! You damn dog. Okay. Fall through. If you don't use a break or return statement, excuse me, after a case's code, subsequent code will exit, excuse me, via the fall through phenomenon. Scope. I think it's defined but unreachable. Like if we say mm, to case 1, and then we could say int y is 5. Case 2, int, or well, y is 3. Yes, it can only be initialized in the last case. Something like that. Not sure about the scoping. I think the whole, or well, the whole statement, the whole block shares the same switch state scope. Go-tos. Can bring you back to earlier code. They muddle or skip code, compiler error, or warning, compiler warning, muddle execution flaw. While executes each time only if the condition is true. Do while executes once, then more if the condition is true. For executes while a loop variable specific amount of times according to a loop variable that is usually incremented, decremented. Break to exit the innermost loop. Continue to skip the current loop iteration. Full trigger the for loop post body logic. Standard abort or standard exit and exit code. Or standard at exit function identifier before calling standard exit and exit code. 9. Seed standard seed sequence. Use standard seed sequence to seed empty. Call empty identifier via uniform int distribution to limit empty number to desired range. 1. Code coverage is the percent of code executed in a unit executed by one call of your unit test. Important to test all code and possibilities to handle errors. Common semantic errors. Common off by 1. I don't know if it's common. Decrementing unsigned. Null statement after condition, maybe. check if standard failed via then clear it and remove the failed input. Remove extraneous via standard clear and standard ignore. Flusser calls standard abort if its runtime condition is false. Static assert does the same at compile time. Helpful for identifying impossible cases. Then check if standard.uf. See if we should terminate program. Implicit conversions are when you pass a value of one type to a function expecting another type. I mean, it seems like that's it has to be a function. Or when we operate on two separate variables, separate types, and the common type has to be found, and the variables converted. Floating point promotion is when a float is promoted to the wider standard data type of double. That's more efficient for some implementations. Same for integral promotions, but to int. Nearing conversions are when data type is converted to another data type that can't hold all of the first data type's values. Static cast target type initial type value explicitly tells the compiler that we're fine with the consequences, or well, with any narrowing conversions. Five, type diffs and type aliases. Let us use identifier to, I don't know, add specificity to variable. Like using radians equals double for our degree, our angle measurements. Helpful for clarity, maybe if a bunch of values use that type. Probably hurts more than it helps because there's no safety, because it isn't a strong typedef alias, and it isn't actually a unique type, just an alias to an existing type. Auto gives the variable the type of the initializer. Um, Auto gives the function return type the type of the returned value after, well, yeah. Instead of checking the returned type value and the returned values type and the return type to see if they match. Using the same function identifier for multiple functions. Parameter count, type, and identifier yields unique signatures for the compiler to differentiate the functions. Ambiguous matches are when the two functions don't have unique signatures, i.e., they have the same identifier, parameter count, and parameter types. Fuck. Function templates? I don't know if I've touched that yet. Function templates. Let us consolidate. Hold on. Function templates. No, because that's just overloading. Because we say add and add for doubles, add for ints. Let us use one function for a variety of cases instead of having to overload it. Its behavior adjusts depending on the type of argument passed to it, I think. And I should say with answers too, honestly. That's what I should say. Char count. How do I? Oh, home. Fuck. These are my answers. Fuck it. Let's just see what happens if I do this. Oh, shit. Okay, that works. Good. Oh, yeah, this is good. I don't have to do that shit anymore. Oh, thank God. Oh, time's up. It's fine. Oh, yeah, true compound statements. Yep. Control structures. Most simple statements are. Difference between definition and initialization. Default initialization does not assign a value. They are left uninitialized. Gotcha. So the point is it's uninitialized, but it's called default initialization because it has a value. It's just whatever value it already had, or that piece of memory already had. And initialization is when you actually assign the specific value. Undefined behavior. Compilers do not assign default values. Okay, so they just don't always assume garbage values. Okay. Flushes the buffer, and that statement about it being destroyed is unclear. Output is sent to the console, and flushing is about ensuring it appears immediately. But doesn't it already appear immediately? I'm not fully understanding how this flush stuff works. Like now working with Arduinos, I get how, um, well, I don't even know really flushing, because there's a buffer of information that the computer can see, because it's USB, and the Arduino can see, and we have to flush it at first. And I don't really know what's going on. It's like it's initializing it, because it has to be done once. It's like it's putting one character through to make sure it's good, and then, hmm. Okay, I feel like we don't really care about the buffer, but I guess I'll see if it's more important later on. The main types, improvement. Yeah, so there's default initialization, copy initialization, direct, list, copy list, and then, oh, true. There's copy list. I guess there's no copy direct, but there's value though, which is 0. Clarify that copy direct is not a standard term. Okay, Jesus. Okay. Hmm. Standard string or not? Okay, so it's just the integral type. Hey, integral types. So there are regular integer types. Hey, there are booleans, characters, and then floating point values, and then voids. Come here, boy. Come here. Come here. Come here, boy. Oh, good boy. You gonna eat me? Don't eat me. Oh. Oh. Signed versus unsigned, yes. Okay. Trying to focus on the hello? Oh, I didn't put a negative. Whoops, bro. Okay, chill out. Just so you forget the negative. Hello. Okay, no more. No, no. Oh, I already got him started. Jesus, dog. Oh. Yeah, no, you see something outside for sure. 100%. I've never even. Yo, stop kidding me. Never mind, they're not destroyed. Okay, they're created. There's some shit here though. That at least they're created at program start. Then okay, they're never destroyed. They just exist forever. Yeah, true. Well, not really. If you just know PEMDAS. Really? Bit set is standard and preferred for type safety. Type safety? Standard bit set is good. Okay. KO. Yes, deduplication is handled by the linker. Yes. 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 Different translation units because they're global. That's the whole point. We're allowing multiple and well, the point is that the different translation units have some global scope shit. If we were including the shit in local scope in each piece, nobody give a shit. It wouldn't have to be inline. We're doing inline because it's a global constant. Inline namespaces are used for versioning. They allow entities to be brought on. Yeah, but same shit for unlock for oh, the point is inline. Wait, so what is the point? Oh, versioning. Excuse me. You do inline. You can put some stuff. You put something in one namespace, and then you put inline for another. That way, I think you could even name it. So you could have like namespace something, and then inline namespace something, and the inline one would become the default. Yes. Okay, so inline namespaces are for versioning. Unnamed just to add internal linkage to everything inside. Inline namespaces for versioning. To say, hey, this is now just like an unnamed, is now included within this parent scope. That way I can put the other stuff, the older stuff, or the potentially newer stuff that I'm working out in a different namespace, and I can name it. That way it's not included in the previous, in the parent namespace. And it won't be prioritized. So all my code could say these functions, and then I could take the old shit and put it in this other namespace, and then make an inline version. And that inline version will actually be called instead of the old stuff everywhere in my code, and I don't have to go in and explicitly change what it was or where it is. Yeah, bro, we know 1 through 7, yes. Bro, you stopped. Ay, ay, ay. Oh, well, that's why. Answers got cut off at the end of chapter 9. Well, cut off. Well, I thought I pasted, I guess not. Yep. Yes. Yes. If it requires a constant expression, makes sense. But yeah, it's done in compile time. Therefore, shit has to be known in compile time. Oh yeah, true. We can also include in debug. Hmm. By default, I think the release build doesn't define or includes in debug. But we could take it out. That way we do get the crashes if stuff's happening. Implicit conversions are called automatic conversions or coercion. These rules are usual arithmetic conversions. Okay. Promotions are done to ensure there at least is one. Hmm. Efficiency and consistency. Okay. At least as wide as the ideal. Well, it seems like they're, I mean, you don't promote them higher. It's like an int to a long and a double to a long double, not promotion. So we don't say it's least as wide. It should be, we promote them to be as wide. List isolation will cause a compiler error, which is a safety feature. Yes. Oh, well, yeah. If I want to just include it, that's a way. Static casts used for non-narrowing conversions, but it does not protect against them. Yes, it makes them explicit. Okay. It's also used for, oh, well, yeah. So you could do like, it's basically, it's for explicit conversions, but we can use it for narrowing. So we could do short to an int, or we could just do short to an int and it's promoted and it's safe anyways. Either way. Ratings is double. That's what I did. For extra type safety, structure classes. Makes sense. Ooh, strong type diffidium. Okay. Well, could do type trailing type syntax. Um, oh, and the auto needs to be defined with it where it's used. But I don't think it's required to be the trailing. Yeah, what are you lying for, bro? Or we're saying return type deduction. Oh, I think I said before you needed to do trailing, but then if you're doing trailing, then what's the point? You're not actually doing it. You're just doing trailing type syntax, which is just what is it called? Trailing type syntax? Trailing data type syntax? Where you're just saying you're just putting the conflicts type later. And then there was some good part of that, but I don't remember. Oh, yeah, so the return type isn't even, well, it's not considered here, but we're saying so it's not even considered in the signature either. Okay. Oh, well, it's exactly what I said. Oh, but same function identifier, parameter count, type, and identify. Wait, what? Oh, for multiple functions. Oh, function. Count, type, and identifier. Identifier, type. Well, count should be in there too. Oh, parameter types, not names. Well, I didn't say parameter types or names. Oh, well, the improvement is just saying, hey, I'm not saying the names. It's just the types. Compiler can't determine it because multiple overloads are equally viable. Hmm. Oh, that's true, because it doesn't necessarily have to be that they're not unique. Sure, they are unique. One's a character, one's a float. But we provided an int. Well, which happens? Does an int get numerically converted to a float, or does it get numerically converted down to a character? Well, in this case, it seems like it's actually equal. So, like if we say, if we say, let's just say void do thing, and it takes a character, and it just does not, it doesn't do anything. Then we say void do thing, float. We say double, and we say do thing for, boom, it's ambiguous. Why is it ambiguous? Because for is an int, so it has to be numerically converted down to a character, or numerically converted over to a floating type. Specifically, it says yes, so it's ambiguous. Can't determine which one. Not just when they're identical, which is a redefinition error. Gotcha. Because then that would say it already has a body. That's one way. But the ambiguity is when they're unique. It's not known which one will execute. Gotcha. And double, 3.14. Does it get promoted? Yes. In this case, I don't think it would be ambiguous actually, because this is a float. And a float would just be promoted to a double instead of getting numerically converted to an int, because promotion takes priority over an int, over numeric conversion. Oh, that was actually a good summary. Okay. Type-specific versions of functions at compile time. Oh shit. So does that mean it actually creates all the unique ones, and then the linker has all these different ones to call, and at compile time, all the different places that they're called are generated? So it seems like it's just saving compile. Well, I don't know if it's saving compile time, but it's saving code running time, I guess. Increasing code reuse. Yeah, because you're using one thing and then having the compiler do the rest instead of you making all the separate little ones. And type safety, that way it handles all different things. Okay, that's pretty sick. Okay, I'll take it. Time to upload.